Okay, Assalamualaikum. Uh, to all my students, MEC351. So this is my lecture video for our chapter 2. This is the recorded video, and you may see this video that after I publish in the YouTube. This is about the chapter 2 that we will continue from our last class. Terminologies and formula, and the example that I already shown you about how to calculate the problem and how to solve the analysis. Okay, so that's how we use the formula to find the properties in the air, as an example of the partial pressure of dry air, specific humidity, enthalpy, and the masses of dry air and water vapor in the room. Okay, this is the example 2.1 that I have shown you in our last class. So for today, we will continue with the psychrometric chart and a little bit about the dew point temperature here. Okay, the dew point temperature is defined as the temperature at which condensation begins when the air is cool at constant pressure. So the formula of the TDP, dew point temperature, is equal to the saturated temperature at that pressure. V means the vapor, so the pressure is for the vapor, not for the atmospheric pressure, not the dry air pressure, but we use the vapor pressure here. So in other words, TDP or dew point temperature is the saturation temperature of water corresponding to the vapor pressure. Okay, as example, like you see in this diagram, okay, we have the liquid water droplets at the surface of our soda can here, right? This is the normal phenomena that happen in our real life. Okay, how it happens? Because the water vapor in the air is condensed at that temperature. What we call the temperature is the dew point temperature. And how to find that temperature? We use the properties table. You find the T set at the PV. So let's say if we can find the value of our PV, P equal to P dry air, PA plus PV, right? So PV equal to partial pressure, pressure at atmospheric pressure here minus PA. So after we have this value of PV, we find that T set. So that T set is equal to dew point temperature. Okay, let's say, okay, so properties table. Oh, sorry, I don't have here. Where is my properties table? Forward. Okay, so this is our properties table. So let's say the pressure here, atmospheric pressure is 101.32 kPa, right? So let's say PA is 99.32 kPa. So PV will be equal to 2 kPa. Let's say 2 kPa. So you have to find the pressure of 2 kPa here at the saturated water pressure table, because now we are going to find the value for the water vapor. So P 2 kPa. Okay, let's say it is 2 kPa, and then the T set of the 2 kPa here is 70.5 degree of Celsius. T set. So at that situation, when the air reach the 70.5 degree of Celsius, so the water will condense and converted, water vapor will be condensed and converted into the water droplet like this. So let's say the air is around 30 degrees of Celsius, but when air is touched or heat transferred with the our soda can, here soda can maybe 40 degrees of Celsius, let's say 40. So the air that around the surface of the water can here, maybe when it reach 70.5 degree, and then that water vapor will be condensed and converted into the water droplets. So that is how we explain the dew droplet happen during the morning. That's why we call morning dew, right? Okay, so that's all about the dew point in our class today. So now we continue with the psychrometric chart. Okay, the psychometric chart purposely used to make the calculation of air conditioning system becomes easier. Okay, in other words, TDP is the saturation temperature of water corresponding to the water vapor. Okay, this is the summarize of the our dew point temperature, or we said the TDP. Okay, so TDP is the saturation temperature, T set. Okay, T set, dew point, TDP. Okay, now we continue with our psychrometric chart. Okay, this is our psychrometric chart. If you see at the top left corner here, this is the chart that I extract from the our X-ray psychrometric chart number 1, and this is from our textbooks, thermodynamics introduction, thermodynamics by Chengel, the author is Chengel. You can find in our Google Classroom. I already put in there. You can download it and use, and you must use this psychometric chart for our lesson today. Okay, so it looks like very complicated, but no, it is very simple, because we see here there are many axes that you are going to find the value for that particular axis, such as at the x-axis here, dry bulb temperature. So all the line here along this axis line, x line, is represented for the dry bulb temperature, and for slope here, this is the value for enthalpy. So if you want to find the value of enthalpy, you have to project the line until you reach this line, this axis. And for the y-axis, horizontal line here, 2, 4, 6, 8, 10. That represent the value of humidity, specific humidity, omega. You can see here the symbol of omega. So this is specific humidity. But be careful, the value here is in the unit of gram per kilogram, not kilogram per kilogram, but it is gram per kilogram. So you have to convert kilogram here, gram to kilogram, by dividing 1000. For every this value you have to divide by 1000. Okay, Okay, so then you will get the unit of dry air, kilogram per kilogram dry air, because this is the unit for specific humidity that we are normally use. Okay, and we have a slope line here. Okay, so this is 15, 20, 25. Okay, now dot line here represent for the wet bulb temperature. So this is the line dot here 25. This is line dot there. This is the 24 dot 23, 22, here 21, and then you get this line 20. So goes on lah. 19, 18, 17, 16, 15, 14, 13, 12, 11, 10 here. Okay, so the dot line here is presented for the wet bulb temperature in Celsius. Okay, and you can see here 10% relative humidity. So this is the phi. Right. Okay, line, curve line here, curvy line here, all along this curve line, the value of relative humidity is 10%. So if you go upper, then we will have another curve line for relative humidity. This is 20%. The other one is 30, 40, 50, 60, 70, 80, 19 until it reach 100% at this line. Why 100% is important? Because we know at 100% of relative humidity, it also means that it is equal to T set. T set, if you recall back, this one, saturation line, 100%. Okay, for the saturated air here at this line, the dry bulb, wet bulb, and dew point temperature are identical. So it means that temperature for wet bulb, dry bulb, and also the dew point is the same if we reach the saturation line here. Okay, if we reach saturation line, or also if we reach here is the T set relative humidity equal to 100%. So we know if we have the T set equal to 100%, also we have the dew point temperature. So it means that at this situation, the water will be condensed. The water in the air as a water vapor will be condensed into liquid water droplet. Yang ni lah berlaku dekat yang tadilah air terkondens. Kalau contoh dekat aircon pun kita ada air kondens kan, air menitik-menitik tu apa berlaku sebab dia mencapai 100% saturation line. Kalau awak perasan dekat barang elektronik, kalau awak baca spesifikasi dia dulu, manual dia cakap dia ada range dia, humidity range for the device operation. Dia kata mesti no more than 95% ke, sebab kalau jadi 100% maksudnya air menitik habis kena electronic components, rosak lah alat tu. Okay, jadi faham dekat sepanjang line ni, saturation line kat sini, ni adalah relative humidity dia 100%, and also dew bulb temperature, dew temperature also sama. Okay, saturation temperature yang ni ya. Okay, let's say sini 25, ni 20, 21, 22, 23, this one. Okay, bukan. Okay, sini 20, 19, 19, 18, 17. Okay, let's say lah kita ambil satu point dekat sini. 20. So saturation temperature dia 20. Saturation temperature ni sama dengan TDP ya. Kita tahu tadi. Okay. Ini adalah wet bulb temperature. So wet bulb also 20. Kita tarik ke bawah, kita akan dapat dry bulb also 20. So betul lah apa dia cakap. At that point, at any point on the saturation line kat sini, okay, dia punya dew point temperature ataupun saturation temperature, benda yang sama, akan sama dengan dry bulb, akan sama dengan wet bulb temperature. Okay. Okay, jangan risau, nampak saya explain nampak pening. Tak apa, nanti kita senang je. Bila ada satu point, kita akan tarik-tarik, akan dapat nilai dia. Okay. So the other things is the volumetric cubic meter per kilogram dry air here, right? Okay, ni saya tak explain lagi kan. Okay, volume cubic. Apa maksud unit volume cubic? Okay, meter cube lah kan. Okay, volume cubic meter per kilogram dry air. So per kilogram dry air. So when the volume over the mass, this is what we call the specific volume. Okay, if we invert this value ataupun this unit, then we will get the kilogram dry air over meter cube. Okay, coincidentally, this is also the unit of density. So you can find the value of specific volume and also the density by looking at this line. So ni satu line dia 0.92, ni 0.91, this one 0.90, ini kan 89, 88, 87, 86, 85, 84, 83, 82, and so on. Okay, so there are a lot of the thermodynamic properties that you can obtain by only using this particular psychrometric chart. But I repeat, but make sure it only be used at specific temperature. If the psychrometric chart says here that it only for the 101.325, which is also equal to 180 m. So make sure if the atmospheric pressure is 0.1325 kPa, only can be used using this chart. If our atmospheric pressure is more than this value or lower than this value, let's say 110 or 95 kilopascal or 90 kilopascal, so this psychrometric chart cannot be used, and you only can use the formula that we learned in our previous class. Yes, all of this value. So all of this equation can be used in any situation, but the psychrometric chart is limited only for that particular pressure, atmospheric pressure here. Okay, so if in our test, if the questions ask if the value of the atmospheric pressure in the question, let's say in our test, if it is 101, or maybe I put it 100 kPa, still slightly lower, but it can be negligible, you can use this psychrometric chart, and also you can use the equation. So it depends on you how to solve the problem. But for our normal in real life, commonly we are going to use the psychrometric chart, because most of the application in our real life is using the atmospheric pressure. It's very rare to use other than 101.325. Maybe if you try to design the aircon at the Mount Everest peak, maybe you cannot use this psychrometric chart. Why? Because the atmospheric pressure will change based on the altitudes. Okay. So I go to the fundamental part first. So what is the importance or function of the psychrometric charts in our air conditioning applications? Okay, as we know, to get the thermal comfort, you have to manipulate or to change the heating, cooling, humidifying, and also dehumidifying, because the thermal comfort is affected very hardly affected by the temperature and also humidity value. So if we manipulate this process, we can achieve our thermal comforts. So that's what we call this process, we call the air conditioning process. Macam dekat rumah lah, beza peti sejuk awak dengan aircon dekat bilik awak adalah peti sejuk adalah refrigeration, simple process. Peti sejuk nak keluarkan haba untuk pastikan dalam peti sejuk. Okay. Berbeza dengan aircon dekat bilik awak, aircon tu guna untuk menyamankan. Menyamankan tu adalah penyaman udara kan kita panggil kan. Menyamankan udara tu, itu adalah condition process, air condition process. Kita tak mau terlalu sejuk, kita tak mau terlalu panas. So kita akan jadi lebih complicated sikit lah proses dia berbanding refrigeration. So basically the fundamental of aircon is still the refrigeration process, sebab because of the refrigeration process is the only concept that we use to remove heat from the conditioned space. But to get the thermal comfort, we have to manipulate this process and use this process to get our goal, which is thermal comfort. Okay, so there are 4 processes that we use in the aircon process. The first one is the simple heating. So heating is to give the heat, to get the heat. The other one is the simple cooling. So the simple cooling is just remove the heat, release the heat to the surrounding, and by simple cooling, the temperature will drop. For the simple heating, the temperature will increase. And it does not mention anything about the humidity, right? But we know the humidity is also a factor for the thermal comfort. So we also have to combine the heating and cooling process with the humidification or dehumidification here. Okay, dehumidification, buang kelembapan air. Kita buang air daripada udara tu. Okay, humidification is you inject water in the air, so you will get the water vapor more in the air. Okay, so naturally heating will combine with humidification, and for the cooling will be combined with dehumidifications. Okay, so the normal situation in Malaysia as a tropical climate country, kita panas kan, so kita nak sejuk kan, so we have to cool and also we have to dehumidify our air. Why? Because we know in tropical countries like Malaysia right now, we have high relative humidity or specific humidity also. So we have to decrease the value of humidity to get our thermal comfort cool. What is our thermal comfort range? Between 30% to 60%. This is what we have learned earlier in our previous video. And so cooling, the target is to get the thermal comfort, where the thermal comfort for the temperature is between 22 degree and 24 degrees Celsius. So that is your target. And for the air conditioning process, heating with dehumidification, this is a normal process in the cool climate countries. Let's say in during the winter season, so they want to get heat to increase temperature in their room. But during the winter, they also have very dry air, means that low humidity value. So if you have low, so to get the 30% to 60% goals that we want for our thermal comfort, so you have to inject or increase the humidity value. So how to inject the water vapor? You can spray the water vapor in the air like this. Okay, so basically in our conditional process, we have these 4 process. In our air conditioner device, we have all these 4 processes. Okay, we have the tutorial or example of calculation here. I think I don't have time to show you for this video. Maybe for next video I will show separately this example in the tutorial video, in the separate video. But for today, I will just show you how to get the value of the psychrometric chart here. Okay. I erase this handwriting first. Okay. So I will show you this example how to use the psychrometric chart. Okay, example 14.4. You also can refer this example in your textbooks, thermodynamics, written by the Chengel and Kimbala. Okay, consider a room that contains air at 1 atm. So surely you must have this value to use psychrometric chart. And 35 degrees Celsius. Okay, here it didn't say anything about the dry bulb or wet bulb temperature. Okay, by default, if it says that temperature of the air, it is the dry bulb. So just put it dB, dry bulb temperature. And 40% relative humidity. So this is the phi, relative humidity. So using the psychrometric chart, determine A, the specific humidity. So the question wants you to find the omega, B, the enthalpy, H, enthalpy, and the wet bulb temperature, so TWB. And finally, the dew point temperature, TDP, right, also equal to Tsat at PV. Just I point it first, so to make sure you do not forget the equation here. And finally, specific volume of the air. So this is the V, specific volume. Okay, now for any chart, you must have at least two properties value. So for our example here, we already have the TDB, 35 degrees Celsius, and also phi, our relative humidity is 14%, 40%. So by using those two values, 35 degree of Celsius, you find here where is 35 degree line. So this 30, this 40, so this line is 35 degrees. So you can use your ruler, just make it a line until you reach our second value. What is our second value? It is the relative humidity. So find our line of relative humidity. The curved line here is the relative humidity, right? So you project this line until you reach 40 degrees. So make it a mark or dot as a 0 point here. This is our reference point. So I already have the value, the line here, and now you can find any value you want in the psychrometric chart. Okay, so for A, we have to find the specific humidity. Okay, once again, if you forget where is the specific humidity, you just find any particular words on this graph, and then okay, I found out this is humidity, but it doesn't state that it is relative or specific, right? Okay, so in our chart it already stated that this is the relative humidity, so this one must be specific humidity. Plus it also give you this symbol omega, so surely this line here is the specific humidity. I use green. So from our reference dot here, you make a line that goes to the humidity ratio. Okay, so based on my eyes here, I see the value is 14, right? So you put it here, omega equal to 14. But remember, I said earlier, 14 here is in the unit of gram per kilogram. You have to get the value in unit kilogram per kilogram dry air, right? So 14 here, you must divide by 1000 to get this unit. So this is your final value for omega. So this is 0014 kilogram per kilogram dry air. Okay, so we have one answer right now. Let's go to the B. The B is the enthalpy. Okay, similar to our first step to find the omega, you find where is the enthalpy in the psychometric chart. So we have here in the slope line. Okay, this is 60, 70, 80, and it also have the slope line here. So use your ruler, make it a line until you reach this axis. I don't have the line, maybe around here, right? Okay, so you have to approximate the value based on its interval. Let's say here, based on my eyes, I have I think around here. This is 80, this is 70, so this is 22, 24, 26, 28. So 22, this is 22, so this is 21. So I estimate the value is H equal to 71. Okay, based on my eyes lah, and my hand ruler here. You must have used the straight ruler, so you will get a more accurate value. And the unit here is kilojoule per kilogram dry air. So that's it. It's simple and easy to get the value of enthalpy. And see the wet bulb temperature. Okay, this is the line that represents wet bulb temperature. 25 here, this is 20. So we have this line parallel to the wet bulb temperature line, and then you have to estimate that value. So let's say this is 25, so this dot line here is 24. This is 23. So we have our line in between 23 and 24. But it's not at the center or middle of their interval. So maybe third quarter. That's why you have to estimate. So the wet bulb temperature here, I estimate between 23 and 24. So maybe 23.75. I put it at the third quarter here. Okay, so that's it. Easy, right? That's why psychometric charts is used for the applications. You can save a lot of time compared to using the formula, the equations. Okay, and D, we have to find the dew point temperature. Okay, dew point temperature is where you make the line horizontally to this line. Okay. So now 50, 60, 70, 80, 90, 20, no? It's 20, 80, 16, no. And you have to count the interval 1, 2, 3, 4, 5, 6, 7, 8, 8 interval, and you have 4 degrees of Celsius. So you have to divide 4 degrees Celsius divide by 8 intervals, so you will get around 0.5. Is it correct? So this is 15.5. No. 1, 2. Oh, this is not 4 degree interval, it is 5. Okay. Okay, so you have to find one interval is equal to how many degrees, and finally you can get this value. Okay, I don't have time. My time here shows 20:49 AM. I feel sleepy, so I will go faster. You try to find by your own here. Okay, it's not difficult. Just divide the difference between 20 and 15 and divide by the numbers of interval, and you plus every interval here until you get the value. Okay, so finally the specific volume of the air. Okay, where is the volume? Cubic meter per kilogram dry air. So this line represents for the specific volume. And from our reference point, you also have to make a parallel line parallel to the specific volume. I try make a ruler. Okay. All right. This is our point. Okay. So you have to make a line parallel to this line. And you find here we have 0.9 and 0.8. So our line is between 0.88 and 0.9. And this line is 0. This line here ni 0.89, right? This line. Okay. So our value, specific value, must be between 0.9, lower than 0.9, but more than 0.89. And then you have to estimate. So I think it is approximately at around 0.89. So this one is 95. Maybe this is 93. Okay, what is the unit? Okay, just copy down this unit. Meter cube, cubic meter per kilogram dry air. Okay, so that's all how to find the properties using the psychrometric chart. Okay, so this is just the tutorial how to use the psychrometric chart, but in the test or the real life, we maybe never use this psychrometric chart for the simple problem here. Why? Because in our previous semester, psychrometric chart will be used to analyze this air conditioning process. Okay, specifically you can find this value, this example here, problem here. Okay, this is when you will use the psychrometric charts to make your analysis here become simpler and easier. So until the next video, I think that's all. And just like I mentioned earlier, the example 14.5, this one, and 14.6, this one, I will show you how to calculate and how to use the psychrometric chart in the next videos. So that's all for today. And don't forget to submit your attendance and also answer my simple task that I will give you around 1 week to complete. And I will meet you again in the next video in the next week. So that's all. Assalamualaikum, salam sejahtera, dan selamat malam. Saya dah pukul 1 nak tidur dah. Okay, bye.